welcome everybody to the fourth video in the BCPC3 solution video series. In this video, we're going to talk about 3, which was the next easiest problem. So 3 is the obligatory problem about the random mathematical properties of an arbitrary number. In the past few years, we've had 1 and 2, and those were about prime numbers, and then they were about highly composite numbers or antiprimes. This one is about the fact that any polygon has to have exactly 3 or more sides. So any polygon that has, for any number of sides more than 3, there's some polygon with that number of sides, and for every number less than 3, there isn't a polygon with that number of sides. So we have you prove the first part of that. So for any number bigger than 3 or 3, there's some polygon with that number of sides, and you have to write some code that will print the coordinates of some polygon. And then there are some requirements on the polygon. It can't intersect itself. It can't have angles that are 180 degrees. And it has to be on only integer points. And then you can list your points in either clockwise or counterclockwise order, however you want to do that. So there are lots of approaches to this problem. Initially, what I thought was the easiest approach would be to do something like a sawtooth sort of thing. So you could like just zigzag up and down like this, you can imagine, and then when you're done, you can just connect to the beginning. So that's one really easy way to do it. Another thing you can do, and then like the thing to handle is if for whatever reason the number of vertices is the wrong parity, for that doesn't work, you can just like go across for one short bit, and then you can start your zigzag pattern for as many sides as you need, and then once you're done, you can connect up here. And that way you can enforce that you always end in this high point. So that was the intended solution, and that uses linear space going this way. So that would work with bounds up to 10 to the 5th. For this problem, bounds were a little bit smaller, just so that I could, when I was checking all of the edges, I could check every pair of edges. I could do an n squared checker. And an order n log n checker exists, so I could have written that and been really confident that, or been like pretty confident I was right. But I thought it would be a lot easier just to make very sure there weren't any bugs in judging submissions. So bounds were really small. Now you could take advantage of the fact that bounds were small by doing this thing. You could do something that looked like this. You could like increase your slope slightly, or yeah, maybe go like this. So you could start with a slope of 1, then you could go with a slope of 2, and with a slope of 3, etc. And when you do this, it's always possible to wind up going back to the origin, because you're like always concave up. So that's a very easy solution to implement. So I think that's what we'll do, because you don't have to case work even or odd. And that's what I'd say maybe about half the teams did. They got it. So we can implement that really quickly. And like another way, like this, you can just add 1, add 2, add 3. Another thing you can do is you can just go over 1, up 1 squared, over 2, up 2 squared, over 3, up 3 squared. And that adds a little bit more than you need, but it's still like gets exactly the target polygon you're looking for. So we're going to need a scanner, and then we're going to need no end. So then we can just print all of our points. Polygon. Just kidding. Okay, so what that would look like, I'll split screen it so we can draw kind of an example. Okay, so we have 1 point here, then we go over 1 and up 1, so we have another point here, and we go over 1 more and up 3, 1, 2, 3, point here. So this does in fact make a triangle. It's kind of an ugly triangle, but it definitely works. And then you can imagine we're going to go over 1 more and then up a lot more as well. Definitely more than 3. It's 4 squared minus 3 squared is going to be a lot more than 3 squared minus 2 squared, etc. So yeah, so that's one valid solution, and it's like super quick and clean code, as you can see. The intended solution was zigzagging, and you can add just like an if statement and being careful with like keeping track your variables and stuff. But yeah, so that's 3. Wound up being a little bit easier than I thought it would be, but still kind of a cool problem. And it was interesting in that there were lots of different ideas you could have that were all right. So kind of a cool problem, I think. Feel free to check out the other videos in this series, and that was the solution to 3.